coming up on This Week in Radio Tech. We're in Orlando, Florida, just about to do an SBE meeting here at WPOZ in Orlando. But my guest, Brian Kerkan, is going to be talking about audio processing past, maybe some processors you'll recognize from when you got into broadcast engineering, and how he's doing things in the future, or actually now converting to it. That's coming up. Chris Tobin's along with us, too, to add his comments about big city audio processing. It's all coming up next on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by the Calrec Type R console system. Type R is a brand new, modular, expandable IP-based radio system from Calrec Audio.
Hey, welcome into This Week in Radio Tech, the show where we talk about radio technology every week, from the microphone to, the light bulb at the top of the tower and all the stuff in between. Good afternoon or good evening or good morning, wherever you are. I'm Kirk Harnack. I work for the folks at the Telos Alliance, and they graciously give me an hour and a half off every Thursday afternoon to do This Week in Radio Tech. And you can tell we're not in the Telos Alliance studio today in Nashville, Tennessee. I have gotten on a plane and jetted my way down to Central Florida near Mouse World, Universal, and SeaWorld, and I'm in Orlando, Florida to do This Week in Radio Tech. And, I would kind of toss it back to Chris right now, but we got this guy right here in the shot. So
Thanks for having me.
It'd be rude just to get away from the shot and bring him in later. Brian Kerkan. Hi, Brian. Welcome in.
Thank you.
I see you're wearing a Telos shirt too.
I am. It's all in style here,
Brian, you worked for Telos for a while.
I did.
Yeah.
Yeah, it was a fantastic time.
Did a lot of audio processing?
I did. I'm a really good friend of Frank's, and that's how we met, is the early days in processing that we're going to be talking about here in a little bit with the Vigilante and Cutting Edge and making processors in the garage and all that fun stuff. But Frank and I were on the roof of the Trimon in Pittsburgh working on a air chain back in the early 90s.
Oh my gosh.
Yeah.
Wow. Well, you may recall, if you're a fan of the show, that Brian and his friend Jim Hogue were on the show a few months ago, maybe in June, July, something like that. And Jim has some great stories to tell. In fact, he was here a little while ago, told us some amazing stories about Glen Clark, stuff that I hadn't heard before, which is most stories about Glen Clark. So what we decided to do is today we're going to look at some really old equipment. Well, I say really old equipment from the 80s that you were familiar with early on. Jim Hogue had a hand in designing. We're going to look at that gear. We're going to juxtapose that with what we're doing these days. What did this gear do for us back then? And what does the current crop of gear do? So we got kind of an interesting show. We do have some show and tell. So if you're listening, hey, you may want to see if you can catch the video version of our show. And with that, let's bring in a guy who's been around doing engineering since the 80s, like me, Chris Tobin. Hey, Chris, welcome into the show. Listen to you.
All righty. Well, just to give some context to what you see here. That's all.
I didn't recognize the tune, Chris. What was that?
It's the foot stomper. It's my feet on the pedals. It's
you must be in your yeah. Go ahead.
The performance space, yes, I am, and just to the side of me is a Hammond C3 organ with a Leslie speaker that you just heard those sounds come from. So that's what that's about. But yeah, we just did a performance recording about 45 minutes ago. We just wrapped up. So I figured I'd just set up here and get going. So here we are.
There's no reason for me not to say this actually on the show that one time I got a free Hammond organ, not just like the one you've got there, very similar to it. It was free with the purchase of a $300,000 house.
Oh, yes, I remember that story. Yes, I remember you talking about that. That's right.
Sadly, it didn't work, and fixing it was more money than I could possibly afford. So my wife and I donated it to the Country Music Hall of Fame, because some country songs had been written. Our crossover country songs have been written on it. So Chris, how goes it in Newark today? What's happening at your station or in your engineering world?
Well, in the engineering world, I just finished videotaping Lioness. It's a sextet of performers, female lady, sax. We have sax. We have the organ player, guitar, and drums. So it was good. And we just did. We had a couple other folks this week as well, so it's been pretty busy. We got about 3 or 4 videos going up on the website, I think, over the next day or so. So it's good.
You know what's curious is we're in a performance space here, aren't we?
We are.
Yeah, we're actually on a stage.
Z88.3.
The Z88.3 logo's behind us, and in front of us, I know you can't see this on the camera, and I can't reach the camera to turn it around, but in front of us is a performance space. There's a live mixing console back here. There's some lighting. There's projectors here in the room, and it's set up right now as a conference with tables and chairs, and we're going to have an SBE meeting in this space tonight. Now, I'll be speaking, but not from the stage. I'm going to go down on, take the podium and speak from there. But we've been here before. We're at the studios of WPOZ in Orlando, Florida. Brian, last time that I was here in this space, I think there's a different engineer here. Randy Wood was the engineer here. And Randy's decided to go make a move.
He has. He's going north to New Hampshire.
Oh, my goodness. From Florida?
From Florida.
Well, at least there's no hurricanes in New Hampshire.
Yeah, they're right.
So, hey, I want to mention something quickly. Normally, when we're on the road, we use Max Connect. Chris and I both use the Max Connect product. This is no ordinary wireless service. And now, hear me out, because if you're thinking, hey, I've tried doing remotes with my cell phone or with a Cradle Point even, or some other MiFi hotspot, and sometimes it works, sometimes it doesn't. Well, the Max Connect will work either all the time or all the times that we've ever used it, because it's not just a Cradle Point industrial, commercial quality modem. It's actually a whole different service. And by service, I mean, of course, it's using one of the big carriers. You can get service on AT&T or Verizon, but what you're getting is something that you can't normally buy on your own. You can get it through maxconnectwireless.com, and that service is a very high level of quality. In other words, there can be a whole stadium full of people on their cell phones during halftime, texting, sending pictures, looking at scores, looking at videos, cat videos, whatever. And the cell sites are saturated, but your data with Max Connect gets through. And the reason it does is because you've got priority over all those jokers in the stadium. You have priority over everyone except first responders with Max Connect. And so your data will get through. Check it out, Max Connect Wireless. That's spelled funny, so look at how it's spelled. It's MAXXKONNECT wireless.com. There'll be a link for that in the show notes. This is what you do use this to do your radio remotes. It comes with antennas like this to connect to your wireless carrier. And on the other side, you can put a couple of Wi-Fi antennas on, or you can do the smart thing and use the LAN connector to hook up to your codec, whether it's a Telos codec or a Comrex codec, a Tie-Line codec, or hooking it to your laptop like we do when we're on the road. Max Connect Wireless is what you want. From Josh Bone at Bone Broadcast. Really appreciate that. And Chris and I both have had great experience with the Max Connect. You guys do remotes?
We do, but most of them are recorded on the phone. Send it into the studio to edit. So,
one thing I've noticed, and Chris, you tell me if things are any different in New York City. I would think in New York, people want to be absolutely live. They want the real deal. But one reason why stations, in my opinion, have gone to doing remotes that aren't quite live, and my stations in Mississippi do this. They go to an event, they record a break, and then using Twisted Wave and Dropbox, they send that file, boom, back to the radio station. And our automation, because of what folder they put it in, the automation just grabs it and will put it in next. And so it's less tenuous than a live connection that may or may not work. So I think that the promise of live wireless working and the not quite delivering of it may have led to stations doing the not quite live remote.
There's a lot of options though. Clean feed we were talking about earlier.
Oh, yeah.
It's a fantastic solution.
And obviously this works with Clean Feed.
It would work with Clean Feed.
Yep. So if you're worried about your data dropping out, then Max Connect will get you through.
But there's many ways.
And typically, audio data rates are going to be 100 to 200 kilobits per second,
That's
right?
Not that much at all.
And this thing, typically, you're getting about 5 megabits per second, but it's not doesn't drop out here and there. It's you get your 5 megabits.
It's fantastic.
So, all right. So thanks a lot, Josh Bone at Max Connect. So today we're gonna let's why don't we jump right into at least one box right away?
Sure.
Just so we don't.
Which one do we want to look at?
Let's do this top one.
Okay.
Here. There were a number of different versions of this. This is a Well, you tell me what it is.
Well, is it the Volumax or Audimax?
Yes, it is. It's the Volumax or
Volumax. Okay. So yeah, these were early day processors. Actually, one of the first AM stations I worked at had these.
Yeah, and these sold beige circuit boards. Now, so that you mentioned Audimax or Volumax, and this show is partly for those of you who don't know. You may not have been around when these things were out, or hey, maybe it's been 25, 30 years since you've seen one. Let's grab the other one,
Sure,
and compare what these two things do. Chris, you feel welcome to chime in with your experiences too. This one is the Audimax, right?
that is correct.
And so, what is the Audimax versus what is the Volumax?
Well, you have a level control.
Yeah.
Basically in the Audimax.
So this one's an automatic gain control.
That's correct.
There's a little man in here with a volume control, and if it gets too loud, he turns it down. And if it gets too soft, he turns it up. Yeah, so audio transformer in there. Well, I wonder where the actual gain block is. That actually, was it electronic or was it a light-dependent resistor? I don't think it was an LDR, but I could be wrong. I don't know. Chris, do you happen to know what the technology was?
No, I don't recall on that one. I think it was just
Feedback?
discrete circuitry.
I think we're looking right
Just feedback?
there.
Oh, wait a minute.
That's it.
Oh, do you think that's an LDR?
I do.
So we're saying LDR. For those who don't know, that's a light-dependent resistor. It's either an LDR or some kind of special
Right.
MOSFET, or there's some special device down in here. I can't quite show it to you.
Mhm.
Now look at this on the back of this old technology. The audio connections. These didn't work with Studio Hub at all.
No. No.
These were.
Well, you could do the pigtails. You could do the pigtail studio.
Yeah, you could do. That's right. You could bring this out to an RJ45.
You could make it work.
Absolutely. Yeah. But this didn't have AES67 in it, or
It did
Livewire, or Ravenna.
No.
Didn't even have Dante.
No.
It did have these.
It hums sometimes.
It would have
That's what it had.
have a barrier strip here, so you do spade lub crimp connectors
Yeah.
to hook those up.
Yeah.
Get your black and red wires. correct?
Christmas trees.
Oh,
on
gosh.
those and patch panels.
This
those
meter,
days.
this meter even had lights to light
Yeah.
to light it up. Now inside, you've got some controls.
Mhm.
Input level, of course, output
Right.
level,
Right.
and a normal or test function.
Right.
I wonder what in test, what would it do different?
Just pass audio, basically.
Okay,
Without having the level control.
okay. So it wouldn't do
It's one
gain
of those days of
reduction.
doing
or-
proofs.
Exactly.
That's right, proofs. That's right. Now I remember working at an AM station in Mount Sterling, Kentucky, and it was a good old tube type transmitter. It was a CCA tube transmitter,
Mhm.
4 tubes, and we weren't trying to be loud. We were just trying to be on the air and sound nice.
Mhm.
And we had this Audimax, and we had the AM version of the Volumax. So the Volumax is here. And I'm telling you, that was the sweetest sounding
Yeah.
radio station. It
Yeah.
just sounded natural and sweet.
We were talking about Glen Clark earlier.
Yeah.
Glen Clark, actually, I worked in Pittsburgh. So that's where I started in broadcast engineering. We'd modify these with a little RC network to be able to roll the frequency response off to get a little bit more brightness.
Oh, okay.
So it's kind of a
Okay.
field mod that he did.
I was looking at that side. So the Volumax, the difference here is that it was a limiter.
Correct.
And the difference, for those, sometimes when we do a basic show, we get a lot more viewers, people looking up a compressor, a limiter is like a little man in here, but he's manic, right?
He's just-
Oh, there's a peak. I'm gonna turn it down. So he's really fast on the volume control. And the idea here, these are both wideband. They weren't multiband.
Right.
So they would take all the audio coming in. If you had a big drum beat, boom, come along, everything dug down, and then we'd come back up, right? Remember that sound?
Oh, I do. Just sucking the audio right up there after that big bass beat or loud announcer.
Chris, you've worked in a couple of small markets, mostly big markets though, and I would, it was very early in my career that I had experience with wideband processors on the air, and because not long after I got started, out came multiband audio processors, at least in my little world. Chris, what was your experience transitioning from a wideband processing to your first multiband experience?
Well, let's see, my one of my multi-band experiences with the DAP 310, the Duro Audio Processor 310. In the early days, it was set up as a matrix, L plus R, L minus R arrangement. But before that was the Volumax, Audimax on several occasions. And then shortly thereafter, I went to working with a product from a company called Nat Hines. Steve Nat was the founder, and that was multiband processing with wideband involved as well. It was interesting. But just for a note on the Volumax and Audimax, I worked up in Stamford, Connecticut for some time in my career, which happened to be that my station was down the block from CBS Labs, where the gentleman who invented and designed the audio curves and everything else you hear today, Emil Tork. And I had the chance to work alongside him on a technology called FMX. And I got to hear some great stories about all those audio tests they did. Was it the Munson, what they call the Munson curves, and a few other things. So it was interesting what went into the Volumax. Yes, it was interesting what went into a Volumax and Audimax design and where things went and how multiband processing has its pros and cons. It was fascinating. So, it was a good time.
So they made wideband audio processors for AM and then different ones for FM. The FM ones had a pre-emphasis curve going on that they were aware of. We're gonna bring out a familiar but old wideband processor in just a minute before we get to the multiband processors, and we got some really cool stuff to show you there. This week in Radio Tech, we're kind of heading back in time, and then we'll pull it way forward in time before the end of the show. We got some really cool technology to talk about that Brian is doing here at WPOZ. But first, I want to tell you our show is brought to you in part by our friends at Angry Audio. angryaudio.com. And if you've been told that Studio Hub adapters and cables are no longer available, you've been told wrong. They are available. You just ask your dealer, say, no, I want Studio Hub from Angry Audio. Or you can go to angryaudio.com. You can get the part number yourself and tell your dealer, hey, this is what I want. Send it to me. The Studio Hub adapters are now available from angryaudio.com. These are the exact same ones made on the same production equipment by the same factory workers to get you this high quality. And this is good quality stuff. This is, the Studio Hub stuff. These wires don't pull out from the RJ connector here. And for those of you who don't know, Studio Hub is a way to get from standard audio connections, typically left-right analog audio, or they might be AES-EBU digital audio, to get from that over to an RJ45 connector. Now, the Studio Hub adapters, they're passive. They don't do anything to the signal. They just reformat it into the connector that is becoming so popular in studio wiring these days because it's probably connecting to an AOIP, an audio over IP device. Now, you can wire a whole plant with Studio Hub standards and have yourself a much easier and quicker time in doing the wiring. And people did that back, in the early 2000s and even through today. Dan Braverman's company, Radio Systems, people would buy that stuff and they really would have a neater installation using all Studio Hub equipment. Well, but then when audio over IP came out, I believe Axie was first with this, and then others followed suit to use RJ45 connectors for analog audio, left and right stereo, and also for AES-EBU audio. And that's what you get from Studio Hub. And I want to point out, I think there's a cable right over there, that blue cable. If you call your favorite dealer and order you some Studio Hub adapters, for every one you order, say, hey, I want my free cable. And you get a free 7-foot-long shielded Cat 5e patch cable. And these can really be handy. They've got a lot of them at Angry Audio, and they're happy to ship these out to you along with your order. We've got some more news about Angry Audio and Studio Hub coming up later on in the show. You're not going to want to miss it. But thanks a lot to Angry Audio for sponsoring the show and for making sure the Studio Hub standard and name and quality lives on. We'll be right back after this from Calrec.
Type R is Calrec's first native IP-based mixing console. It is fully AES67 and NMOS ISO4 and ISO5 compatible as defined by SMPTE 2110. Connectivity via Cat5e utilizing COT switches and power to the surface is supplied via standard PoE switches to minimize cabling. Its 2U core has integrated I/O, so you're instantly up and running, and it can power up to 3 independent mixing environments, each with their own separate DSP resources. Type R's surface is modular and expandable, consisting of 3 slimline panels, each of which are user-definable with layouts saved and recalled quickly between shows. It's available in 4 DSP packs, and as your station grows, larger packs can be added, making Type R the most flexible radio console you can buy. Find out more at calrec.com/TWiRT.
Thanks a lot to Calrec for sponsoring This Week in Radio Tech. Hey, it's Kirk Harnack along with Brian Kerkan, and Chris Tobin is with us too. We're talking about some older audio processing technology because here at WPOZ, well, there's stories about old audio processors, and we might have time to get into one of those. But we've been talking about wideband processing. We started with the Audimax and the Volumax from CBS Laboratories. They made those things. I want to say they started sometime in the 60s with those, and the earlier ones were tube type. Right? They had tubes in there. The ones we showed you here were an intermediate model. And then the last ones they made were like one RU, one rack unit, silver. And they had this meter in the front that had this pointer like this.
Right. I have one in the back.
Oh, you do? Oh,
I
okay.
can maybe grab it out of the rack.
But everybody, if you're an engineer and you're as old as me or Chris or Brian, you probably recognize the next thing we're going to show you. What is this, Brian?
This is the 8000, the Orban 8000.
Orban 8000. This was the, I guess, the first commercially successful processor from Orban.
Yeah. This is the first one I used in FM.
And it's a wideband audio processor. It does have a separate high frequency limiter, which kind of makes it a 2-band processor. Yeah. Kind of. Okay. Chris, was this the first FM processor you were familiar with?
No, actually, the first one, believe it or not, was the what do you call it, the Audimaxes. Then it was the DAP, and then it became an Optimod FM, the 8000.
Oh, dude, you're old. Oh, wow.
Yeah, sorry, but yeah, the 8000. The 8000 has started the craze of single button control for audio density and loudness. That started. That's what got things started.
So there were a couple of motivations for Bob Orban designing the 8000. Well, number one, he wanted to make money. But number two, he felt that if you combined it used to be these things were separate. There was you had the Audimax
right
compressor. Then you had the Volumax limiter, a separate box. And then you had a separate stereo generator. And all these boxes were separate. And Bob said, there's some problems here that I could solve by putting this not just all in one box, but designing them to work together to some degree, right? Mm-hmm. And he felt he had more control over it. So that's why the Orban 8000 became so incredibly popular. And very sweet sounding, not the loud, well, certainly not anymore. It's not a loud box, if you will. It doesn't make a lot of full use of the modulation that we can do. Remember that this one doesn't have a security cover on it, does it?
It doesn't. A lot of them didn't after they were in the studio.
Yeah. Have you ever seen these with this one has one lone Phillips screw still laying here. You ever see people replace them with weird screws?
Oh, I have.
Yeah.
The security screws.
Security screws.
Right,
yeah.
Right.
So nobody could open it.
Right. They hated it.
I was the engineer for a while at a rock station in Lexington, Kentucky. It was 98 Rock Double Q. And we had one of these. I think in the chain before it, we ended up putting a couple of CRL processors. But we had one disc jockey who would take the cover off, and there's a release time. Tell us what the release time does.
It just changes the ratio of the way that the timing is on the limiter.
So a slow release time is less density. A fast release time is
correct.
That little man who turned it down, as soon as the loud stuff goes by, he's going to turn it back up again real fast.
Correct.
And
it gets busy.
It gets that's a good word. Fast. Busy. It gets
very busy.
Now, some people think they like busy. Other people say it's fatiguing to listen to.
Right.
I would say the 8000 was never a fatiguing box to listen to.
No, back then it wasn't as competitive as it is now.
Yeah.
Audio.
But on this release time, there's a control, and you can have it from slow or dial it around to fast or turn it about a quarter turn farther, and it was limit only. In other words, it had no more automatic gain control action. It only had it only had at that point limiting action. And so, hey, I'm getting a call here, and look who's on the phone. Hi, sweetheart. Hey, this is my wife FaceTime me. So, hey, we're doing the show, so I have to call you later. All right, bye. Got to stay in touch with family.
That's great.
So, so this one disc jockey would turn it to limit only, and I could hear this on the air.
Sure,
I could hear it.
Sure,
I'd say, dude, It sounds different. Oh, I didn't do anything.
That's true. Those are the days, though. Everything being an adjustment. You know, I have a story. My wife hated the greenie.
Oh, the greenie screwdriver?
Oh, yeah. I had it in my center console because I was always, listening. And if I would run to the station, I'd have it there. And I'm like, give me a few minutes. I'm going to go up and take care of things. Half hour later, still sitting there.
So the greenie was kind of like the Widowmaker for her. It would take you away. Well, he loves his greenie more than me.
Yeah, pretty much because of these adjustments here on the Prisms.
Yeah. Oh, yeah. That's right. That's right. And anything. Oh, yeah. The same disc jockey later on who would claim I didn't do anything would later claim I got permission to make it sound better.
Right.
Fine, whatever. Hey, people regard you as a processing expert because you are.
Some. I love audio. I love good audio.
Have you ever worked at a station where you just the best thing to do was to just say, "Okay, Mr. PD, you adjust it however you want."
There's a lot of different positions out there as far as what sounds good. So, depending upon who the stakeholders are, a lot of times my philosophy would be is I would travel to consult.
Mm-hmm.
I would try to get everybody that was going to have a voice involved. And I would use their car actually to try to set the processing up, because instead of them coming back later and saying, I heard this, like the production director that got involved, or, the person, the receptionist at the station. Most of the time it was the production director, though. The PD would go to the production director and I don't think that sounds quite right. So we would be out in the car, or we would go into the production room where we had reference monitors and involve them all and try to come up with a plan. It's amazing how much, even just small adjustments,
mm-hmm.
How they would say, yeah, I heard that, even though you wouldn't adjust anything. It's like, does that sound better? Yeah, that sounds great. Not that I would do that much, but, for you don't want to have a longer day than what you needed to have. And if you involve everybody, right, and they would all say it sounded great, you didn't have to worry about coming back later. So that's how I dealt with it.
So there's a number of philosophies about this. And so engineers, maybe you can relate this to how different personalities are at your stations with audio processing. The first time I was in New York City, actually, at a major station in New York City. And it's a different language station than English, so we tend it's a different community of people that tend to listen to that. But I had the job of going there and updating some firmware in their audio processors, and we agreed to do this for the station. And the engineer was as nice as he could be, great guy. And I said, "So how do you adjust the processing?" He said, "I don't." What do you mean? He said, I let the PD adjust it.
Right.
And this was in the early days of remote control adjustments of processing. So the processor was at the transmitter site in the Empire State Building.
Right.
And I was floored, not upset, but just, really? New York City, you don't adjust it, you let your PD. He says, look, that PD has paid a lot of money. Actually, he's paid more money than me. And I don't want to fight with him. I want him happy.
Right.
And you know what? I showed him the different controls and how they make the station sound, and then let him go for it. And honestly, he said, some of the music played on the station, I don't get it. I don't understand it. It's not, I don't know what it should sound like to the ear of our ethnic listener. And so I let the PD do it. And he said, it's great. The PD actually does a great job with it.
Sure.
And I'm absolved of the responsibility.
Mm-hmm.
So, Chris, I'm curious about you. Have you run into that kind of situation where the PD has the keys to the processor and it's good?
Actually, all the stations I've worked with, both full-time and freelance, the PD would not work on something unless the engineer was with him.
Okay.
And that was their personal taste. I have worked with folks who have had the situation where the PD, did everything. Yeah. Hey, there's nothing wrong with it. It's just, we as the technical people should make sure we keep an ear and an eye on the readings to make sure that everything is working properly after they've played with it. Because I've been in places where I've gotten a phone call and said, "Can you help us? We have a problem, distortion on the radio. We're not sure what it is." And I get there, and the person in charge of audio processing, cranked everything. So that's the only drawback. But no, I've worked for spoken word stations, we've done sports, news, and I've done music, and every one of them has a different approach. And I've worked with program directors for the old news station that I've worked with, and we spent many nights, many weekends, many days. He'd be driving around listening and calling me from the car and asking me to make some changes remotely. He says, "What do this? Try this. I think this will sound better." And I'm like, "All right, we'll give it a whirl." And we got to a point where the station had a signature sound and stayed that way for almost 12 years. And nobody, we never touched it. Never anybody tried to make a comment to something, he would say, "No, we're done. We're fine." That was it.
Well,
when we're making the money, we're doing well. No, we don't need to be playing around. We'd had consultants come through all the time for suggesting stuff, and he just look at him and goes, "You're here to take care of the editorial. The audio is done. Now move on." And I've sit in meetings and go, "Okay, you're making more than I am. I get that, and you have the authority to say these things, but I join the show. So I bring out the popcorn, I sit back and wait for them to be told, nope, you can't do it. Sorry."
So I want to hear from Brian about, is there some unusual processing story? And I'll open yours up by telling a little short story of my own. I had been hired at a station in Memphis to do some contract work, and the first thing was to fix the audio processing. And so I walked in the station one night I was going to do this in the evening, and I came in there, and I don't remember if he was the former owner or the former GM. Somehow he was allowed in the station. He was laying on the floor because the processing was at the bottom of the equipment rack. Why, I don't know. With a greenie screwdriver, laying on his tummy, looking at the processing, adjusting it, and he had a bottle of vodka next to him. And I thought, you know what? There's no improvement that I can make over what this man is doing.
He was having a good time, right?
He was having
in his own way. Why not? Maybe it sounded better after that. You never know. To him.
You know what? We found that the real problem with the station was it was a beautiful music station.
Right.
And one of the playback machines, the playhead was so out of alignment that the station was transmitting just a ton of L-R. The left and right channels were out of phase at many frequencies. Mm-hmm. And so I lined the head up, and the new manager said, "Station sounds great. What'd you do?" I said, "I fixed the tape machine."
A lot of times it just gets down to the basics. Good source material, right?
Yeah.
So in the case of bad heads back then, or even now, making sure the levels are consistent, making sure that things are recorded properly and they're not clipped, making sure that you don't play MP3s on the air. It's amazing how many stations out there still play MP3s.
You bring out a good point about MP3s,
too, not just music.
Yeah, you're right. Oh yeah, one of my stations has such a bad commercial on it. One thing about MP3s is that when they first came out 20 some years ago, a lot of us thought, that sounds amazingly good. And actually, I heard some demos where I couldn't tell the difference between linear and MP3. Back then. Now my brain knows what the distortions are in MP3, and I can hear it. But back then, it wasn't crossover distortion, and it wasn't clipping distortion, so it wasn't a distortion my brain knew about. So I thought, it sounds pretty good. What folks don't realize, and hey, if you do anything with MP3 or other coded audio, you should know this. Coded audio was designed to sound reasonably good as long as you don't have multiband audio processing after it, because it does result in added noise and some interesting added distortions. And if you do nothing else with the audio from that point, it's probably not going to bother you, at least not very much. But if you then do especially multiband audio processing to it, it's going to lift those distortions up out of the subconscious and into the conscious, and you're going to hear these problems.
There's a clip of Suzanne Vega, Tom's Diner.
Oh yeah, I love it.
Plays just the artifacts.
What?
You can hear the artifacts in the MP3 codec. I don't know if you ever heard that, but it plays the ringing and some of the some of the noise that's eliminated.
Okay.
The difference of what's eliminated. But having good source material, making sure that your STL path is clean. I've gone to stations already that major stations actually that there's a problem in the exciter, or there's a problem with the level going into the transmitter. There's one station that was modulating 75%, and they bought an Omnia 9, right,
to fix their problem.
And they didn't. You're right, and they didn't want to go out to the transmitter site. And I was looking at the mod monitor, and I'm looking at the modulation. I'm like, you gotta take into account the whole picture, because if you over process, because of another issue.
Bad.
It's bad.
Yeah, they can't. They'll never be good.
You're starting out with a compromise.
Yeah.
So why not look at the whole picture?
Over processing to overcome an obvious deficiency in where you need to be in your modulation. In that case, that's like trying to go 90 miles an hour in second gear.
Right.
That you're not going to be successful.
You're
with
just
that.
pushing against a brick wall and pushing harder. That's all. And it's you can hear it. It's terrible sometimes when you hear a station that that's what they're doing. Turn it all up, and it's loud, but it's terrible.
So we're gonna tease the next segment here. Let's go ahead and show people the front of this box, and then we'll talk about the insides and some story. Look at this, Chris Tobin. Let's see. Let's get that in the picture. There we go. Here, I'll hold that.
Okay.
What you see what that says, Chris?
Yes, I do.
It's Texar. And a lot of us kids who came up in the 80s, especially the mid and late 80s in audio processing, kids like me, that name held some special meaning because it was a cool processor that came out.
Definitely was.
We bugged our GMs to get a Texar.
In the greeny adjustments were right.
Right other side, over there.
Yeah.
But this one is different because
it is.
There was never one. This is not a production model.
It's not. It's a prototype.
It's a prototype. There were about 16 of these made, I was told by Jim.
This one was in New York City, I believe, according to Jim.
Well, we're going to talk more about this and how this came about and where it went after that in just a minute. Our show This Week in Radio Tech, we're reminiscing, and as soon as we're done talking about the Texar, we'll find out some cool things about it. We'll talk about where Brian is taking his stations in some good technology to make them sound just absolutely beautiful. That's coming up next after this word from Broadcasters General Store.
The Aaron 655 is the latest addition to the Inovonics family of rebroadcast receivers, designed specifically for FM broadcast translators, also referred to as relay transmitters. The Aaron 655 is unique as an uncompromising DSP-based HD radio and FM receiver combined with a powerful 3-band audio processor and dynamic RDS encoder. IP connectivity adds streaming capabilities, and a web browser interface gives you total remote control of the unit from any PC or mobile device. The Aaron 655 gives you maximum flexibility for program sources. Select program audio from analog FM, digital channels HD1 through 8, streaming sources, and analog or AES digital line inputs, all with assignable failover audio backup. The internal RDS encoder allows you to customize your RDS messaging. You can use incoming off-air RDS data, convert HD radio pad data to RDS, convert streamed metadata to RDS, or receive IP telnet data. Comprehensive audio processing includes gated and windowed AGC, a unique syllabic leveler, 3 bands of compression, and both wideband and independent HF limiting. Easy setup is achieved by using 10 factory presets and 10 customizable presets. The processor also supports day parting, allowing automatic preset changes to follow different programming formats throughout your broadcast day. The front panel has an OLED display and jog wheel with intuitive menus for easy setup, advanced control, and editing for all operating parameters. The Aaron 655 dynamic web interface gives you total remote control of the unit from any PC or mobile device. A comprehensive set of menus includes a quick overview of now playing info, input-output control, processor options, RDS encoder, alarms and notifications, SNMP settings, and much more. You can also listen to the live audio broadcast streamed through the web interface.
What's also cool about Inovonics products, you can demo for yourself most of their products if you just go to their website, inovonicsbroadcast.com. inovonicsbroadcast.com, and they have online demos of the Aaron 655 and lots of other products, the Sophia line and others. So you can play with the controls yourself, just like you would if you had the product and had the web interface. And I think that is absolutely amazing. Inovonics is available from Broadcasters General Store, BGS. The website is bgs.cc. And their phone number, you can memorize this. I certainly have over the years, 352-622-7700. And in fact, I was just at BGS yesterday and spent the whole afternoon with the crew at Broadcasters General Store. Delightful people, and they are serious about getting you the products you want at a really fair price, often the best that you'll find anywhere. Come on in, Brian, and also they help you track your orders. So their customer service, and I know people say customer service this, customer service that, blah blah blah. They are really good about this. So Dave, Carrie, Jessica, Carly, Jonathan, everybody there, Hugh, just do such a great job. So thanks a lot, BGS.cc, for sponsoring This Week in Radio Tech. All right, Brian Kerkan is, you okay?
I ran across to the studio to get this.
We'll look at that in a few minutes. So what we're looking at here, this Texar, this is an early Texar Audio Prism. It doesn't say Audio Prism. Was that named later?
I think so.
Okay, but the Texar, Glen Clark was one of the designers behind this. I guess kind of the.
Look at that meter wiring. It's it's telephone wire.
Oh my goodness, it is telephone wire.
This was an early prototype.
So this is pretty much hand built. I do see capacitors that have been twisted on and added around and solder connections made. So this, we talked earlier about wideband, where you have like one man with a volume control inside. Mm-hmm. This is multiband. So you have different audio. We take just like a graphic equalizer, we take the audio and we separate it into sections. So we have the low band, the mid band, the presence band, and the high band. And so 4 different spectra of audio. And there's the idea here is to let a little man with a volume control work on each band individually and make each band the right volume or an optimum volume, and then combine those back together to a final output. Now, there's some tricks to designing this, especially in the analog world with analog components, and that is getting the mix to come back together right so things are still in phase, that things didn't add in some wonky way. So the design of the filters is really important when you do this. So
for sure,
they did as much optimization as they could back then. Nowadays, in the digital world, we actually can do even better optimization of that. But and then there's a ton of controls on the front. Talk to me about some of these controls up here.
Well, you have your mix levels and the gating. So you set the gate levels so it will freeze, the band whenever the threshold is lower than the gate setting. Density. You talked a little bit about
the release time and density.
Right. So density, you can make the sound louder overall by making it more dense. Mm-hmm. You had your individual band controls that you had here, and you had your proof setting, and some of these also had the ability that you could generate noise and test point on the production model.
Yeah. Wow.
Yeah.
These were later. So, I mean, the production units were smaller, right? They were 1 rack unit tall,
right? Because
they didn't have meters on them like this. They had rows of LEDs,
right?
Yeah. The idea. Or the thing that I remember the advertising about the Texar Audio Prism was Glenn made a point to say that all other processors are either compressing or they're expanding. They're compressing or not compressing. In other words, they're always moving. They're always busy. The Texar Audio Prism is smart enough to, if it needs to do nothing, it will do nothing.
Exactly.
So if it doesn't do anything until the audio falls outside of a range.
Correct.
Possibility.
Sort of like the dynamic EQ that is in the on the 11.
Oh, okay.
The concept of the dynamic EQ.
Wow.
Yeah.
Wow. I worked at the first time I ever saw one of these in a station. Was a station where once you scoot on this back here, was a station where the engineer didn't want anybody to know what he was using. And so, of course, he not only did he put put not just smoky plexiglass, but he put a metal cover over the front of the Texar Audio Prism. But if you took the metal cover off and you saw the Texar Audio Prism on the faceplate where it said Texar Audio Prism, he scraped the paint off.
Like people wouldn't know.
Like people, wait a minute, I saw that advertised.
What they wouldn't have known is the extra cap that could have been added to change the crossover value in one of the multiband, like the 8100 we have with the XT.
Yeah.
One of the modifications was to change the bass crossover frequency. And there were other modifications you could do, the clippers and whatnot.
So we're going to talk about the digital stuff here in just a minute.
Sure.
But there's one more thing I wanted to ask about. A lot of people used Texar Audio Prisms with the Orban 8100.
Mm-hmm.
And the 8100 itself was kind of a two-band processor, wasn't it?
Yes.
And there was some feeling that card number 5 in the 8100 that was responsible for some timing and things,
right.
That it didn't always play really nice with a pre-processed multiband signal. And so I guess it was Glen Clark.
Right, the RCF5, I believe, was the card.
Yeah, he came out with a new, you take the Orban card 5 out.
Right.
Yeah, and you put the RCF5 card in that Glen helped design, and then it says, hey, you send me multi-band processed audio, I'm gonna make you proud.
Right.
Chris, what are your recollections about that setup in New York City?
Oh, that was a classic combination, and yes, there were plenty of mods to do on a Prism as well as the 8100. One of the things, if you look at the schematic design, I remember reading the patent on the smart clipper in this the Optimod before Texar came around. And the way it's designed and the way Bob took approach to the audio clipping and the methodology behind it, the two-band processing that he created, it was pretty ingenious. And if you really take a step back and you say, wow, that's pretty cool, then take that same thinking, and then when you have the Texar in front of this box, you suddenly realize why you need to condition the audio going in. The safety clippers inside the Optimod, and there's other stuff that suddenly now the thresholds where they were designed are being maxed out. So once you understood that combination, my stations I worked with, we did wideband compeller in front of the Texars, and then Texars in front of the Optimod. I used to just disable the two-band processor and use the smart clipper function, and work that way. And you can get some really cool sounds, and it was interesting. You got to remember, what you put in, you get out. So if you put it in trash audio, you're going to get trash audio out. It's just going to be clipped harder and sound really strange. But if done smartly, you can have a really nice sound, very loud, very dense, because that was the big thing back in the 80s and late 70s, early 80s, was all about the density and who's louder on the dial, because it's got to pop out on the dial. And the race to sound loud was interesting here in New York City, I will tell you, and in Philadelphia when I did some work with friends, and even Boston. So it's fascinating when you look back at this stuff and go, oh yeah. And remember, on the Texar, the 1RU Texar, you had the test point, voltage point on each band, each card. And a lot of people are like, what's the point of that? What's the point of that? Well, if you're a consultant and you want to say to a station, you can sound like the guys across town, here are the voltage settings you need to reach. That's what you do. But the problem is, as a friend of mine who was an engineer here in New York City for many years at a very, very popular top station, used to tell me, he goes, look, all three of us could be in a room with all the same processing, and I guarantee you we'll not be able to copy each other's settings, even with the Simpson 360, 260 sitting there and measuring the voltage points. And as a lark, we did that one night. Of course, we did work at the Empire State Building one night for Master Antenna Works. We decided all get together in a room and go, hey, let's have some fun, because we've got to be here from 11 p.m. until 4 a.m. So let's have some fun. And sure enough, we proved the point. We had 3 people with 3 sets of processors, and nobody can make them sound the same. Where else to do it but in the number one market, and say, yep, it's true, you can't do it. So you got your own signature, go for it. But the Texars, Glen Clark, got to give him credit. It was a brilliant approach, made total sense the way he went about it. And anybody who poo-pooed the product, because I know there were a lot of folks that didn't really understand the approach. And you need to look at it from several factors. One, yes, he's making money. God bless him. 2, he's producing a product that if you're smart about how to use it, you too can make money and enjoy yourself. So I think you got to look at the foundation of the early days of processing and really appreciate it. Because even Mike DeRoe with the DAP systems had people thinking about how to do stuff, how to sum multiband, how to approach it, how to do these things. So it's pretty cool. And today's digital stuff makes it even easier. But if you don't understand the fundamentals, you can make them sound just as bad as those days of old.
It is interesting that we do need to understand, as you said, the fundamentals, what happened in the analog world, and the frustrations. Well, you don't have to understand the frustrations that we had, but one thing that we understand now, and we were working through it back then, was how much influence the FM exciter had on the sound.
Oh yeah,
and we developed audio processors that could actually break the exciter. They could make it unlock and quit transmitting
PLL.
Because of bass notes that were now powerful and chest thumping bass. All of a sudden, boop, my transmitter kicked off. Why did it go off? Oh, too much, not too much bass, but too much smack in the bass and
mean
the
the
automatic
frequency shifting
circuitry
of
of
the
the
carrier?
transmitter. Yeah, carriers. Yeah.
Carrier shift.
The AFC would unlocked would unlock. So
Oh, if
we've
you
been
had
talking about
RCA
this.
exciters, they used to do that.
Yeah. Well, and I mean, I'm not naming names, but the Harris MS-15 had a single speed AFC circuit, and they would come
another
unlocked
classic.
with some of the multiband stuff.
Mhm.
So that's why, if I understand correctly, I hope I got my history right. Jeff Mendenhall, or maybe it was Richard Fry, but somebody came up with a dual speed AFC for the that made the MX-15. Which wouldn't unlock. And then at the same time, BE came out with the FX30 exciter, which apparently was quite a breakthrough at the time. It really sounded good compared to anything else and would handle this really dense modulation produced by the hot-rodded audio processors. But now we have digital. And there's some very cool things we can do with digital, very repeatable things, and we can build an audio chain that I mean, except for dynamics processing, the ones and zeros that come off of the CD or whatever the original material on, we can essentially get clean audio at the other end that we're going to transmit. And Brian, we've gone through years, even decades of iterations of new ways to get digital audio from a studio out to a transmitter site and transmit it. We've been over the years making different parts of that chain digital and come up with new ways to hook them together. Brian, you've got something in front of you that's right here,
Sure.
and I'm a little bit wondering what's so special about a cable with a thing on the end of it here.
Well, this is a Canary transformer adapter, 110 to 75 ohm. So what it will do is we're going to be converting over to Omnia Direct, which will be the 192 kilohertz, digitizing the composite, and then sending it over a interplex to the transmitter.
So let me untangle a couple of things there.
Sure.
Typically when we have digital audio in a format like AES-EBU, often called AES3, so that's left and right audio in a digital format, and it can be carried over coax or over twisted pair wire. And that's typically sampled. Well, there are different sampling rates: 32 kilohertz, 48 kilohertz, could be 44.1, could be 96. You just said 192. Now, that high speed is not so the audio has an airy quality about it. No, it's not for that. And we're not talking about oxygen-free cable here. We're talking about sampling at this super high rate, 192 kilohertz, because this is more than just the left and the right.
That's correct.
You said the composite signal.
Right, the pilot, the stereo difference, the whole package.
This is the multiplex or MPX signal that comes out the back of that Orban 8000 that we looked at.
Correct.
Comes out of it. So as you said, the left plus right, the pilot, the left minus right, and in this case, no RDS on top of that. But that whole signal right there, Jeff Mendenhall 30 years ago wrote some papers about that's actually a fragile signal. We got to be careful with that. So we can't mess that signal up or you'll have bad audio on the air, and you may not know why. But you're saying we could, and we've done this for some years now, we can digitize that signal, make it into an AES-EBU compliant stream. The stream format is actually it's not a stream like an AOIP stream, but it's digital audio on a cable, compliant with AES standards, 192 kilohertz, and it contains everything the exciter needs to know to transmit perfect stereo audio
directly into the transmitter.
Now, what comes out of the Omnia?
The Omnia 11 has an Omnia Direct XLR, and it's the 192 kilohertz 24-bit sample of the composite.
Okay, so it's an XLR male output.
Correct.
And if you put headphones on, you're not going to hear anything.
No, you're not. It's digital.
It's digital 192 kilohertz sampling. Okay.
So what we're doing in our case is we want to have redundancy. We have two Omnia 11s, so we're using a BDI switcher. So it's 110 ohm with a 75 ohm, actually 75 ohm input. So we're going 110 ohm, 75 ohm into the switcher, and then out of the switcher back to 110 ohm.
Now with a digital audio signal that is sampled really high, so it's almost like RF. It's
correct.
It's not quite as high as gigabit Cat 6 cable, but why is the impedance important? You've been saying 75 ohm and 100 ohm.
Well, it
Sounds
just
like a
has
couple
to be
different standards.
well, it has to be matched. And the idea here is, you want to use a cable medium that will handle that higher sampling rate. What's found is with twisted pair, at least from BDI's perspective,
Mhm.
I was discussing it with them, that they recommended us doing it on coax
Okay.
just because of their past experience with having issues here and there. I've done it both ways. I've been able to feed a Nautel transmitter direct with just regular standard 110 ohm cable, but this was their recommendation.
So this is a transformer. It must be a tiny transformer in there.
It must be.
And it's wound. You wouldn't put audio through this. You wouldn't put analog audio through it.
No.
In fact, it says on the side here 0.1 to 6 megahertz. So this will pass high frequency digital data.
That's designed for it.
Okay, and part of the purpose, it changes the impedance, the 110 ohm standard output on an XLR to the 75 ohm for the coax, which you could probably run this quite a number of feet.
Yes.
Yeah, because it's all 75 ohm stuff. But it also, if you had a ground loop problem, which you might not hear as hum, but you might hear as the digital audio working or not working from time to time, this will break that, right?
Correct. Give you some isolation.
Isolation. Interesting. So you're coming out using one of the brand names is Omnia Direct, 192 kilohertz AES EBU composite. And then you're going to go into what?
Interplex.
An interplex.
Right, an IP-100.
Oh, so you're going in with which format? The 110 or the 75?
We're going into the IP-100 back is 110.
Okay.
Right.
All right. So that'll take this AES EBU digital signal, this high frequency sampled signal, and put that into IP packets?
Correct.
And send that. We figure the bit rate 4.5 megabits per second.
Correct, and we have a gigabit pipe. So,
okay,
we're fine as far as the transmitter and then our backup link.
So at this point, this AES EBU data is getting put into packets now.
Correct.
In the Gates Air Interplex.
Correct.
And then being sent across public internet or
we have our own private.
Private network.
Private.
Okay.
Network, right.
Out to the transmitter site.
Correct.
At which point it goes into another interplex out there, which turns it from what? Packets back into.
That's what it does.
Back into this.
Right.
Okay.
Yeah.
All right.
And just shoots right over to the exciter on the transmitter, and it's beautiful. I mean, you can't get much better than that.
On the one hand, all these conversions seem a little laborious. On the other hand, each step in the chain is using the transport technology that's appropriate for what it's doing.
Correct.
Yeah. If your transmitter was right here at the studio, you wouldn't you wouldn't put it in the interplex.
No, I mean, when I came in on board, the experience I had working with Omnia and just with the processors in general is you want to use the whole capability of the 11. So by pulling the AES audio out direct without using the final clipping section of the 11, you're giving up a lot of what the processor has to offer.
Which is what you're doing now.
Correct.
Yeah.
So the whole idea is by going with this, you get the whole package as if you were directly connected to your transmitter. And across the network, the traffic is prioritized, so it's protected from the other traffic that's on the network.
I'll put and I asked you about this earlier. So you're delivering left right now before you go to this system.
Correct.
You're delivering left audio into an exciter.
That's correct. Into the Nautel exciter.
And the Nautel exciter has a built-in stereo generator.
Correct.
So that's doing that part of the job for you, but that's not optimal. Why?
Well, you're not getting the final section of the processor will do the peak limiting, and you're able to do tight peak control all the way up to the end. And the stereo generator in the 11 is optimized for delivering the best modulation control. I think I forget what Frank called his 1 plus or whatever.
One louder
technology, but really, when I did the first conversion over to Omnia Direct, I had a transmitter that was close by, and I was actually using standard analog composite into the transmitter, and I converted over to the Direct, thinking, well, it'd just be a small, minimal difference. It made a huge difference.
Well, and maybe Chris can speak to this too. One of my friends, he does development at the TELUS Alliance, is Hans von Zutphen. He's been on our show before, And Hans has kind of proven through some testing in the Netherlands that an FM station will sound better and be receivable in stereo much farther if you can get the noise floor way down. That is the noise floor of what you're telling the exciter to modulate.
Exactly.
And if you're doing an Omnia Direct or AES192, well, that's 24-bit, I think we found out.
It is 24-bit.
And that means you've got a noise floor that is way, way down there. You're not modulating a little bit of, in the audio. And so Hans's experiments, and I think other people's, own experience, turns out, wow.
Hans is quite a guy.
He's
out at NAB, there were several times we went out to Area 51, so it was a lot of fun. and
looking at stuff. And other designers like Leif Clayson would tell you the same thing, and Frank Foti as well too. Yeah. Cleanliness is really next to godliness.
Well, it is. You're going to such extent to build a plant. When you invest in this kind of equipment, you want the very best. So why not handle it end to end that way? It just makes sense.
We're going to have a tip of the week because we've got Chris Tobin here, who never lets us down, and Brian Kerkan is during the spot break going to think of a tip of the week.
Okay, I'll do that.
Well, you got years of processing experience. The number one thing you're forgetting about audio processing. Our show This Week in Radio Tech is brought to you in part by our friends at Angry Audio. And I know we've talked about them before already in the show, but I want to make sure you know about what Angry Audio has done with Studio Hub gear. Now, Studio Hub not only makes adapters like these cable adapters, but Studio Hub has for years made all kinds of things to help you out in the studio electronically, like headphone amps and match jacks. Those little match jacks in a little bitty format that's got inputs and outputs, dongles, splitters, and couplers there, as you can see on the screen if you're watching, power supplies to power these things, different panels to do functions with your audio console, mic preamps, buttons and jacks, even mounting supplies and hardwares and plates and things like that, plus things like the hubs and patch panels if your whole plant is Studio Hub. Well, guess what? All that, or a good part of it, is going to be available again. The folks at Angry Audio are making sure that the most popular items from Studio Hub are once again available, both some of that through some old stock that Studio Hub had, and also some of it manufacturing new stuff. And guess what? If you've got a Studio Hub Millennium audio console, parts are still available for those through Angry Audio, angryaudio.com. Now, in addition to that, there's a whole range of gadgets and gizmos. And I forgot to ask Suncast to pop this up, but if you can find the page on the Angry Audio site for their gadgets or their gizmos and just show a few of those. They have some really cool things. We talked on this show quite a bit about their headphone amp, and it's an interface device that will also light up the tally light on those beautiful Yellowtech mic arms. And the folks at Angry Audio make a beautiful device to do that. There's a headphone amp from Angry Audio, and look at how that one's designed. You won't skin your knee on that because of the smooth design. It goes under your audio console, and it's just terrific because you won't bang your knee on that and come home bleeding like some disc jockeys I know have done. Angry Audio has really wanted to make your life a lot easier when you wire your studio or have to retrofit. Hey, maybe you've got a headphone amp that's busted and you need to fix it. I've had those in my studios. Of course, it's usually the disc jockey being a little rowdy that ends up busting those things. But Angry Audio's got you covered with all kinds of devices. They have other devices too, what they call, there's gadgets and there's gizmos. I never can keep those straight. There's right there on the screen the guest gizmo. This has a built-in headphone amp, headphone volume control, an on-air tally light and cough button, and the electronics to light up the beautiful LED ring that you'll find on a lot of these mic arms nowadays. So check that thing out. I got to tell you, it's a great day to have these new products available from Angry Audio and old products from Studio Hub available as well. So look them up on the internet, angryaudio.com. Their products, most of them are available through your favorite dealer, most if not all. And if you take advantage of their special, and that is that you buy some. Oh, look at this! Look what I found. And I found a box with some more of this stuff at my house. If you need tip ring sleeve, 1/4-inch tip ring sleeve, to an XLR, you got that. And for every one of those you buy, you get a free 7-foot patch cable. AngryAudio.com. Sure thank Mike Dosh and his team there for resurrecting Studio Hub and also designing their own really cool stuff. All right, it's time for a tip of the week. Chris Tobin, can you help us out this week with something we can't live without?
Well, since we're talking digital and the world is moving in that direction, I think it's time for many of you to begin investing in AES test equipment. I have a couple of little boxes, the little Whirlwind boxes and Wardbeck, the Bit Buddies and stuff. I don't have them with me. And they've come in handy lately. We've been doing some work recording with Maddie and some on-location concerts. And a lot of the stuff we're now plugging into is AES. And I've had many occasions where for some reason something's not working. I'm like, wait a minute, took my box out, took the AES connection, plugged into my box that breaks to a headphone output. And I told the recording guy, I'm not getting any AES. He's like, what? No, look, the box is blank. Or I'm getting dropouts, something going on. I plug into the box, look, I'm getting errors. There's an error light, the fault light's coming on. So the reason you do this investment, yes, it's going to cost you a couple $100 for these little gadgets. And once you put them in your bag, you got it. But think about the amount of time lost troubleshooting without them at an event, whether it's a live location outside your studios or in the studio, and you've got people waiting on you. The trick is not to have people waiting on you for troubleshooting. They should be waiting on you to get things done right. You have to remember. So since we're talking digital, that's the thing to do. Invest in some AES test equipment. I have, and for the last 7 years, the boxes have not failed me once. And trust me, I've been in court in a couple of places where if I didn't do it right, well, I mean, I had a little tin cup on the corner and those chestnuts roasting during the fall because Kirk knows some of the places that I've been in, it's like they don't take failure as an option at all. It's like, you can't get it done? Really? I thought we hired you to do a job. The door's there. So,
yeah.
Yes, I'm not kidding. I'm serious. You should invest in test equipment that makes sense and it's worth it, well worth it. And if you're doing STLs and you're converting over to digital, wouldn't it be nice at 3 o'clock in the morning when you're at the transmitter site and you're being told there's something wrong? You just pull out the little box, plug it in, and go, yep, that's definitely not coming over from the studio correctly. And then you can continue troubleshooting on. So you can verify that your signal is either not coming in or is with an independent box, not the box in the rack that may be failing and causing the problem that you think exists somewhere else.
Good point. The right test tools, and they're different than they were 30 years ago when we all had butt sets, right?
Yeah, the Chrome jack connector and the Banana plugs and the butt set. Yeah, no, you can use that to test to see if there's static there. That's about it, but that's all you're going to get.
Yeah.
I use the DB box too. It's a really nice box.
Yeah.
It's a blue box with a speaker in it.
Yeah.
You can test the data stream. And then I picked up a Chrome plug. So you can plug it right into the Chrome block, in the middle there and just test right there. It's invaluable. That's for sure.
You big city slickers. I've never had a Chrome block anywhere.
Oh, the Chrome blocks are a hoot because if you do them right, you can make a patch bay out of them. But it's just, you've got to, if you want to reverse phase on your audio path, just make a Chrome connector, flip the wiring on it, plug it into the center, and you got yourself a reverse patch. But the testing with the boxes is great. I mean, I have my little AES box with a speaker built in. I can test. I mean, it's just great. It does save time. And it works. It's well worth the investment.
Good deal. Thanks a lot, Chris, for that tip of the week. Brian, you got something for us?
Well, I would just say as far as processing goes, we've been talking a lot about the different aspects of processing. I would say less is more, right? So instead of boosting, cut, right? Listen to the spectral balance of what you're trying to do and don't give it too much. Just add in enough feathering to the audio and just let the audio processing do its work. It takes a little bit of time to listen to make sure that you have consistency across source material, but it's well worth it. That would be my tip.
And my tip would be to take your advice that less is more and apply it especially to your web stream, because you're not in a loudness war. I think, in my opinion, and I've written a couple papers on this, you're in a consistency war on your web stream. You want that to be the same volume at 2 p.m. and 4 p.m. and 10 p.m. over time. Now, you want to have some dynamics in there, but you also want, you want to be able to set your Amazon Echo, I didn't say your name, and have that thing be at the same volume and not have to tell her, who shall not be named, Speaker of the House, louder or softer. You want to be good and the same, which doesn't mean a wall of sound. It just means long-term consistency.
Yeah.
All right. Hey, we got to go. Brian Kerkan, I have enjoyed you
Thank
being
you.
here.
It's been great.
And I know you can't see it, but behind the camera, they're getting ready for our SBE meeting here in Orlando, Florida. I want to thank the SBE in Orlando for inviting me to come down. We're going to be talking about these new technologies of IP, things like this. This is an intercom system for television or radio that works over IP. It's even powered over IP. So no central matrix in this thing from Telos. It's Telos Infinity. We're talking about that kind of new technology and how it's the way to go these days. It just works and works well, and we're developing more and more tools to make it work. Thanks a lot to our sponsors, but also to our producer, Suncast, who produces This Week in Radio Tech. Really appreciate you, and also appreciate Andrew Zarian, the founder of the GFQ Network, home of lots of fine podcasts. We got to go. You guys have a great day, and we'll see you next week on This Week in Radio Tech. Bye-bye.